And then there's a version. Now we're going to leave this version off for this first setup, and I'll explain why later. But basically, we want to see what version we're going to get before we freeze it. Now this is good practice because sometimes these docs are not updated. It's very unfortunate, but the docs are not always the latest docs. So I recommend leaving any version off of any new modules until you know what version you're dealing with, and then you can provide that afterwards. There's also a Terraform will hold those versions in place. Now after we've done that, we're going to configure the AWS provider by providing a region. Now this is also where you would provide your credentials. Now if you're not on AWS Cloud 9, you may need to provide these credentials. So if you just read through here, you can actually see all of the different ways to provide authentication from the most insecure all the way to environment variables, and then you can actually get down to assumed roles and some of the better practices. But again, since we already have a role assumed within our Cloud 9 instance, we're going to stick to the basics. So I'm going to get back over to my Cloud 9 console and let's type this out. First of all, let's go ahead and create a directory for our project.
Namanya Terraform.
It's a new folder, and I'm just going to call this mtc-Terransable. You'll see me use this word in a bit. Now within that, I will create a new file, and I'm going to call that providers.tf.
All providers.
Generally speaking, I prefer to split these things off because you'll find that as you grow your infrastructure, it's going to get a little unwieldy, and you're going to want to kind of keep the important things in important places where they're easy to find. So I'll open that file, and then we're going to create that first Terraform block, just like so, followed by require _providers. Then we're going to specify AWS, and we're going to specify that source equal. Source equals HashiCorp/AWS, just like so. Now once we've done that, let's go ahead and provide that provider block. Provider is AWS, and let's just provide a region. Now I deployed Cloud 9 and US East 1, and I kind of don't want to screw some.
Provider WS source-nya kita belajar HashiCorp di sini. HashiCorp OS.
Something up or get things confused, so I'm actually going to deploy to a different region. I'll be using US West 1, but you can feel free to use any region you see fit. Just know that certain regions have different free tier requirements. Generally speaking, T2 Micro is going to be okay, but make sure you do review that to ensure that you don't incur any charges even though they may be very small. Alright, so that is actually all there is to this. Go ahead and mark this.
Provider sorry. Regionnya sama yes, West Oregon itu berapa sih? Show Oregon US West 2. Loh, kok dia pakai US West 1 sih? Gue US West 2 aja. Wah. Samain aja lah. Show US West 1. Okay. US Terraform. Jadi basic cd provider. Oh ya, gue harus punya shared credential. Dia bisa copy sendiri lah. Dah, biji kali ya. kredensial profile dengan tutorial.
This lesson complete, and in the next lesson, we're going to initialize it. Hello and welcome back. In this lesson, we're going to run the terraform init command, which will initialize our terraform directory. It's going to run several steps, which we'll see. Now do note that it is safe to run terraform init multiple times. They actually mention that a lot in these docs. So feel free to read through these docs if you want to take a look at some of the more advanced features.
Terraform docs. Kalau long comment gitu gimana? Long comment comment. Biar panjang gimana ya? Comment snippet aja anjir. Terraform ada. Oke, ada. Sip. Better coming up. Shit. Terraform OS initiate, terus ini kredensial ini
There may be some to run into later in the course. But for now, we're going to keep it pretty simple and head back into our terminal, change directory into our NTZ transfer directory, and we're going to run terraform init, just like so. All right, as you can see, found the latest version of HashiCorp AWS, just like we specified. Installing HashiCorp AWS 3.63.0, which is great, so we could freeze that version to something like this and be perfectly safe. And this, of course, is just saying that it successfully installed. Now, one thing that it's done is it's created a lock file, terraform.lock.hcl. As you can see here. So this actually is locking this version for you. You don't necessarily need to provide that version restrict here because you've already got it in your lock file. So if you pass this lock file to your version control system, such as GitHub, GitLab, or what have you, then this file is going to ensure that everyone downloads the correct version. Now the only thing to keep in mind here is that if this version gets deprecated to the point where it's not available anymore, that's generally not going to happen with AWS, but with some other third-party providers, that can be an issue, which is when you may want to specify and hardcode a version here. But for the most part, we're not going to have to worry about that. We're actually going to use our lock file here. If we find that one day you're not able to utilize this version anymore, then it's probably time to upgrade and test anyway. So we're not going to bother with the version here. We're just going to utilize this Terraform lock file. And let's take a look at what exactly Terraform init did. So if I go over here to the tree on the left, if you don't see these hidden files, the dot files, you can click this sprocket right here and just click Show Hidden Files. This is also useful to hide them again if you don't want to see them. So if we open this up, we can see there are a lot of new directories, but for the most part, they're all empty except for their one subdirectory. So we go to providers, registry.terraform.io, HashiCorp, and then AWS. Now, as we add new providers in the future, you may see those here. You then see the version, you then see the architecture, and then right here, if we open this, this is basically our compiled Go provider. Everything in this is compiled and is how Terraform is speaking to the AWS API. But we're not going to really dive into that in this course, as it's a little bit outside the scope. So just going to minimize that now. So now everything is all nice and initialized, which means we finally get to deploy some resources. So go ahead and mark this lesson complete. Come on back to the next one. lesson, we're going to finally do what we've been waiting for, terraform apply ourselves and build something. Now it's going to be something simple, we're just going to start with a VPC, but of course it's going to get a lot more fun and complicated after that. So let's go ahead and create our main.tf. This is where all the magic happens. Now, it doesn't have to be called main.tf. There's actually no significance other than it's generally the primary file for Terraform in any repository, but you can name it literally anything you want. We can name it terraform.tf or derek.tf, whatever you want. Any TF files will be processed the same by Terraform. So just keep that in mind, but try to stick to main.tf. So let's go ahead and by derek.tf, whatever you want. File for Terraform in any repository, but you can name it literally anything you want. We can name it terraform.tf or derek.tf, whatever you want. Any TF files will be processed the same by Terraform. So just keep that in mind, but try to stick to main.tf. So let's go ahead and open that, and then let's head over to the docs. You're going to find that you spend a lot of time in the documentation because I don't know about you, but I won't be memorizing all of these resources. So we're here in the AWS VPC resource. Now, as you can see, it can get very, very simple. We're going to add a little bit of extra information. We're going to have a CIDR block, but then I also want to ensure that DNS hostnames and DNS support are enabled as well. So let's roll down here, and as you can see, enable DNS support actually defaults to true. So that's great, but DNS hostnames defaults to false. So I'm actually going to provide both of them just so if someone wanted to change this, they could see that it could be changed. So let's go ahead and do that. I'm going to head here to my main.tf, and we're going to first start by typing resource. This is very important. Resource is a reserved word. So you type resource first, and then of course specifies the type of resource that they're going to deploy, whether it's a VPC or Flowlog, network interface, all of these things you can possibly deploy are all resources. So we'll start with the resource. Next, we define the resource that we want to build, which is
Namanya
AWS
apa ya?
VPC. This is also very important. This is required. As you can see, this is the AWS_VPC resource. Now, the next part is the name or reference to this resource. This can be almost anything you want. So I'm just going to call this the MTC VPC. Now, don't get this confused. This is not a tag. AWS does not know this at all. This is strictly for Terraform and referencing this resource. But this will not be carried over into AWS. If you want to name your VPC, we'll provide a tag. We'll show how to do that. All right, we open and close the braces there. And now we're going to provide our CIDR block. And I'm just going to do 10.123.0.0/16. You can use anything you want as long as these two octets are zeros, but honestly I would probably keep it 10.something under 255.0.0/16. Alright, and then we're going to enable DNS hostnames equals true, and enable DNS support equals true as well. Now finally what I'm going to do is add tags. So tags equals, and these tags are going to go to AWS. This is not just a logical thing, this does go to
What
AWS.
is happening?
Tag on the resource. So for tags, we're going to give it a name tag of MTC_VPC, just like so. All right, that is honestly about it for a simple VPC. So I'm going to save that, and then I'm going to run Terraform plan first. This will ensure that everything is configured properly, and we don't have any major typos or anything like that. Now, it's not going to figure out all configuration issues, but it will be able to tell if you missed an equal sign or if something in the syntax isn't right. Just like so. As you can see,
Jadi example VPC apa namanya? My VPC. My VPC. Cewek tercantik sekecamatan. Oh, ini pakai ini nih. Harus dalam
this needs
string.
to be in quotes. So that's an example of something that this can pick up. Since the slash is here and there are dots, this is a string. This is not just a number. So, thank you very much, Terraform plan. A great example. So Terraform plan. All right.
Thank you
now,
very much,
plan.
Terraform plan. That's a good example. Oke, dapat. Coba kita lihat ke AWS coba. AWS. Oke, sebelum jam 4 udah selesai sih ini. Bisa nggak ya? Who knows. Oh iya, sekarang itu ya. Gue baru kemarin gue nonton AWS Reinvent. Loh, kok salah? Oh, username salah, pantes. Up. MFA. Sabar say. Anjir, di lagu Bang Toib. Oh, jangan di Oregon, men. Tuh ya begini-begini nih. Yang bikin mahal. Gak mahal juga sih, bikin apa? Bikin pusing.
So as you can see, it's going to create a new VPC, and these are all of the pieces of information that will be exported from this VPC. And of course, we'll dive a little bit more into this in the future. There is 1 item to add, 0 to change, and 0 to destroy. Now, we could have also provided an out parameter that would have allowed us to export this plan and then use it again and apply, but we're not going to bother with that. So now that everything looks right, that's exactly what we want to do. Let's go ahead and run a Terraform apply. All right,
Oh iya, Terraform apply-nya belum, Cok. Auto approve.
do you want to perform these actions? Yes, we do. All right, apply complete resources.
Di itu mana sih?
There's 1 added, 0 changed, and 0 destroyed. So let's go and take a look in our console. So I will just click on
Baru koncol. VIP. Oh, di sini kan bisa. Cok. Sus. PC. Oke, berhasil. VPC ada. VPC. Nggak jadi. My, bukan 172. Aku yang satu lagi berarti. Yang 10123 My VPC, oke. Sip, ketemu.
this here and go to dashboard, services, and of course VPC, just like so. And I'm going to move over to my US West 1, where I specified that I wanted to deploy this. And there it is, MTC VPC, all deployed. So perfect. Go ahead and clear my screen here. Now let's go ahead and mark this lesson complete. Hello and welcome back. In this lesson, we're going to take a look at how Terraform maintains the state of your infrastructure. And it
Bentar. Kita namain dulu. Ini VPC. Shader block. Oke, provider.
It does that with a state file. As you can see here, we have a new file called terraform.tf_state. And if you open that file, we can see that basically what we just deployed, that VPC, is all here. Now, I'm probably going to say this a million times, but I'm going to continue saying it. Do not modify this file except under very dire circumstances. Terraform provides very good tools to modify this when you need to that will keep things from getting all out of whack. So once again, it's great to have this, but please do not modify it. Just use it if you need to find something out,
Alright,
at least
sir.
in most cases. Now we've seen what that state file looks like. It's basically just a JSON file. Let's see what happens when we destroy. We run a Terraform destroy, and I'm just going to add auto approve here, which will skip asking us whether we want to or not. I strongly recommend you do not do this often, but it is nice to have whenever you're trying to speed things up in a lesson. I'm going to run that. Alright, everything is now gone. We have destroyed our VPC. It does not exist anymore. If I head back over to my VPC pane, we can see it's gone. All that's left is the default VPC. As you can see, we've got another state.
Keren banget, baru tahu. Damn, jadi kita nggak usah apa namanya? Anjir keren banget Terraform. Kayak ini bisa jadi harga jual gue nih. Ini perak apa harga jual. US West 2 coba. Tutorial VPC kemarin tuh. Oh iya lu. Subnetnya dibuang nggak? Oh iya, sepertinya dibuang juga. Damn, keren banget.
File here.
Kita nggak
TF
usah.
state backup, which is what we had before. Now our new TF state is pretty much completely empty. As you can see, we've got a version and a serial and a lineage. Now if we open up both, we can see that our TF state.backup has a serial of 1, a version of 4, and the lineage is actually the same. So we can tell based on the serial which one is newest. And if there are multiple states or something gets kind of out of whack, the one with the highest serial is the one that Terraform is going to prefer.
Okay.
So I'll go ahead and close those. Let's take a look at a couple ways to see what's in the state. One thing you can do is actually use a great tool called JQ. So if we run sudo apt install JQ, just like so, we run a terraform show-json and pipe that into JQ. We can see, even though we don't have a state anymore, we've got some information from a
Sudo apt install JQ. Rahasia. Terraform show JSON pipe. Lah kan udah install tadi. Lah nggak ke-download berarti tadi. Terraform show JSON pipe. Oh itu sih.
state. So let's clear and run one more apply, terraform apply, and I'm going to add auto approve to this one. All right, that VPC is coming back online. You can obviously see how useful Terraform is when it comes to deploying resources.
Bener ya?
All right, all complete as you can see. There it is again. So now press up a couple times here and run that command again.
Panjang.
There is our state. With JQ, you can actually filter for the things you want to see. I'm not going to dive too deep into that, but during the course, there's a good chance we may check that out. Let's take a look at another way to view the items in our state. So if we run a terraform show, we can see our state in a little bit of an easier way to read. It doesn't include all the state information, it just shows our resources. Now if we run a terraform state list, we actually see our resource without any of its information. So this is a really good way to just find out what resources have been deployed. And of course we can also use grep on these things. So if we were to say terraform show, one more second, let me find a good one here. Let's say we want the CIDR block. So if I were just to do terraform show grep CIDR block, just like so, there we go. So we got exactly what we need. It's not exact science, but it works. So as you can see, the state is very, very powerful. Please ensure that you are not modifying anything in the state. And very, very soon, we're actually going to migrate this state to the cloud, to Terraform's cloud product, so that we don't have to worry about screwing it up here. Because the state can be very, very dangerous if it's deleted. All of a sudden, Terraform has no idea what's left in your environment, and you are stuck deleting everything manually, which is not a fun time. Feel free to go ahead and destroy it.
Okay.
In this lesson, we're going to take our
destroy.
state that is stored locally and insecurely on this terminal and move it to a more secure and reliable place. We're going to be moving it to HashiCorp's Terraform Cloud product. Now, there are several types of Terraform backends that you can use. One of the most popular ones is also S3, but in our case, we're going to use HashiCorp's product because
Terraform apa show JSON JQ emang apa ya, tahu dari JQ coba apa JQ itu, a command line JSON processor that use a domain specific language. A command line JSON processor.
it's secure and easy to manage. So let's get started. Now the first thing I'm going to do, since we destroyed our infrastructure on the last exercise, I'm going to go ahead and reapply it. Just like so. This is so we'll have a little bit more in our state so we can kind of see the migration process and everything that we're doing to get things working once we move over to the cloud. Alright, all set. Our VPC is deployed once again. Now I'm going to head to terraform.io. I've already got an account, but if you do not, go ahead and click on Terraform Cloud and create an account. Now it's a pretty straightforward process, so just go ahead and follow through that, pause the video, and once you're done, come on back once you get to the organization screen. Alright, here we go.
Oke, terraform.io. Oh ya. Berarti sama CloudFormation gue belum pernah coba sih. Fabian, my name is Fabian Hugo. Oops. Oops. I will never say never. I will fight. I will fight till forever. Lah. Oh ini dia. Nggak punya taring, nggak punya cakar lah. Kok takut?
We are, as you can see, I've already got a couple of organizations, but I'm going to go ahead and create a new one. So I'm going to call this mtc-taransible, just like so, and I'll keep my email address the same, and create organization. Alright, so once we've done that, we've got a few options here. We've got the version control workflow, which allows you to deploy based on GitLab or GitHub commits. Now, that's something we're going to do in this course, but we're not going to do it through Terraform's workflow. We're going to use our own, which gives us a lot more customizability with our pipeline, of course, but we're not workflow and create organization.
Ya, waktu tadi namanya Terraform Automation. What? Did I name that? Oh iya bener nih. Tak. Terraform Ansible. EMB Terraform Automation, jadi Terraform Ansible. Oke.
Alright, so once we've done that, we've got a few options here. We've got the version control workflow, which allows you to deploy based on GitLab or GitHub commits.
Gimana nih?
Follow through that, pause the video, and once you're done, come on back once you get to the organization screen. Alright, here we are. As you can see, I've already got a couple of organizations, but I'm going to go ahead and create a new.
Create an organization mana? Ya, mana anjir? Oh ini dia. Go Terraform. Loh, gak bisa ini. Oh ini dia. Terraform Ansible. Yeah. Who goes now? Fabian.
So I'm going to call this mtc-taransible, just like so, and I'll keep my email address the same, and create organization. Alright, so once we've done that, we've got a few options here. We've got the version control workflow, which allows you to deploy based on GitLab or GitHub commits. Now, that's something we're going to do in this course, but we're not going to do it through Terraform's workflow. We're going to use our own, which gives us a lot more customizability with our pipeline. Now, what that means is basically Terraform Cloud requires you to have an enterprise contract to be able to run locally. So if you need to run an Ansible script, for instance, you can't do that without the enterprise contract, which allows you to have local runners. So what we're going to do is just settle for the simple CLI-driven workflow, which will allow us to store our state within Terraform Cloud. But other than that, Terraform Cloud won't be performing any other operations for us. Now, there's also the API-driven workflow, so if you wanted to create some sort of really cool React app that deploys resources, that's the route you would go in that case. So let's go ahead with the CLI-driven workflow, and the workspace name I'll just call Taransible. Once again, do whatever you'd like, and create workspace.
Ansible. Ansible. Okay, workforce created.
Alright, so Terraform Cloud has done some of the work for us by providing this example code. Go ahead and copy that, and let's head back into our terminal real quick. And what we're going to do is create a new file called backends.tf, just like so. Open that file, paste in what we were just copying, and save that file. Now let's head back over to the cloud, and let's make a few more modifications. First things first, what we need to do is go to execution mode. As you can see, it says remote. Now, we do not want the remote executions. Again, we have to run some local things coming up, like Ansible and other items that require us to use our own terminal. Right now, Terraform is not going to be able to run those items because it's not going to have the proper SSH keys and the proper apps to do that within their runners. So go ahead and click that and choose local, just like so, and then save settings. All right, head back over to the overview. Now, click your avatar up here at the top. Go to user settings.
Bentar. Weh, sabar weh. Loh kok ungu gitu doang? Oh emang gitu ya? Nggak penyetaring, nggak penyetakar lah kotak ke.
And we've got our tokens right here, the proper SSH. Go to execution mode. As you can see, it says remote. Now, we do not want the remote executions. Again, we have to run some local things coming up like Ansible and
Gila tulisan nggak kelihatan aja.
the other items that require us to use our own terminal. Right now, Terraform is not going to be able to run those items because it's not going to have the proper SSH keys and the proper apps to do that within their runners. So go ahead and click that and choose local, just like so, and then save settings. All right, head back over to the overview. Now click your avatar up here at the top, go to user settings, and we
Oke, avatar, user setting,
got our tokens right here. Go ahead and create an API token.
ada token,
And I'll just name this Taransible create API token.
Terraform, Terrapatrick aja. Terraforming.
Okay. And make sure you copy this token now. It will not be displayed again. So go ahead and copy that and just leave the window open until we've gotten logged in and everything works out. Of course, if you do lose a token, no biggie, come back and create a new one. And then of course make sure you clean them up as you
Shit, hilang. Alas, jadi good. Ouch. Yank. Aduh, bego. Ini Terraform token. Yang ini GitHub password ya, jangan lupa password. Top token ini password.
as you lose them, which is something I need to do. So now, head back over to our terminal. We're going to run Terraform login.
Oops.
And yes, we would like to proceed. Just do keep in mind, this credential will be kept in a plain text file. Not ideal. So if you're taking this to production, you may want to find a more secure way to get logged in, but we'll take a look at some of that in the future. All right. And now we paste that token in, and we are all set up. So once we've done that, now what we need to do is reinitialize our workspace. So Terraform,
Lah loginnya gitu doang.
but we'll take a look at some of that in the future. As you lose them, which is something I need to do. So now, head back over to our terminal. We're going to run terraform login. And yes, we would like to proceed. Just do keep in mind, this credential will be kept in a plain text file. Not ideal. So if you're taking this to production, you may want to find a more secure way to get logged in, but we'll take a look at some of that in the future. All right. And now we paste that token in, and we are all set up. So once we've done that, now what we
Dah, kan udah.
need to do is reinitialize.
Lah gimana?
A2. So this and you do that and just not API token. We've got our tokens right here. Go ahead and create an API token. Once again, I'll just name this to Ansible, create API token. And make sure you copy this token, Ansible, create API token.
Ansible.
And make sure you copy this token now. It will not be displayed again. So go ahead and copy that and just leave the window open until we've gotten logged in and everything works out. Of course, if you do lose a token, no biggie, come back and create a new one. And then of course make sure you clean them up as you lose them, which is something I need to do. So now, head back over to our terminal. We're going to run terraform login.
Ya, apa sih
And
kalau
yes, we would like to
upload
proceed. Just do keep in mind, this credential will be kept in a plain text file. Not ideal. So if you're taking this to production, you may want to find a more secure way to get logged in, but we'll take a look at some of that in the future. All right. And now we paste that token in, and now we paste that token in.
Oh, oke. Ya. Tokennya masukin token. Ah. Loh, kok login cancel anjir?
And all right. And now we paste, but we'll take a look at some of that in the future. All right. And now we paste that token in, and we are all set up. So once we've done that, now what we need to do is reinitialize our workspace. So terraform init.
What the fuck? Ini apa sih? Oh mungkin itu kali ya, nggak di itunya ya, harus di directory yang ada si itunya dong. cd compute ls cd terraform ansible terraform login yes. Bego anjing, kenapa tetap generate token using your browser and copy paste into this prompt. Terror will store a token in client. Males banget ya. From login. Yes. Okay. Untuk nextnya kita taruh from login lagi. Yes. Fucker anjir. Kan gue udah ganti lokal. Kenapa keluar session terus? Oke, create API token. Copy and pass in your tuh dah. Aneh banget anjing. Oh gitu caranya. Oh ini aja lah. Yes. Oops. My bad. Jadi my file grabs, oops, and vim grabs. Oh, S undo. Oke, apa namanya? Ini color scheme-nya apa ya? Pitch path. Pendidikan. Vim. Mantap. Mantap. Oke, bismillahirrahmanirrahim.
Once again, Y is all set up. So once we've done that, now what we need to do is reinitialize our workspace. So terraform init. Once again, and there we go. Do you want to copy existing state to the new packet? So yes, we do. Just like so. All right, it says it's successfully configured. Let's head right up here to our cloud once again. Click done. Let's go back to our organization. Click on our workspace. Just like so, and let's take a look. All right, so we have some resources here. Let's take a look at our state. All right, we have our state here, which we can filter on and dig through everything that we've deployed. Of course, this is going to get a lot more complicated as the course progresses. So everything is done here.
My VPC. Oke, gimana caranya? Oh, states. Where's the states? States, where is states? What the fuck is states?
All right, we have our
Ter Ansible. States. What the where the hell is
let's head
states?
right up here to our cloud once again. Click done. Let's go back to our organization. Click on our workspace. Just like so, and let's take a look. All right, so we have some resources here. Let's take a look at our state. All right.
Oke lah, let's go lah, nggak apa-apa.
Right, we have our state here, which we can filter on and
Ada
dig
nggak di
through.
sini? Q&A. You might be in wrong region. How to take state and VPC access in a Terraform workspaces.
through everything everything that we've deployed. Of course, this is going to get a lot more complicated as the course progresses. So everything is done here. Go ahead and mark this lesson complete. Come on back to the next one, and let's continue. Hello and welcome back. In this lesson, we're going to step
Mana nggak ada state. Ya gue pengen lihat. Tapi di mana? Oh ini, di bawah gini. Tuh beda gini.
step aside for a little bit and play with our state some. We're just going to run a few commands and just kind of see how to parse the state in different ways just to see what type of resources we have. So let's take a look. As you can see here, I am back in my Terraform Cloud Console, and if I head to states right here and click on my state, we can see that there's some filtering information here. Now if we click on this here, we've got a nice little tutorial on how to do some filtering. Now we're not going to go too deep into this. We might play with it a little bit more as we get filter. There's some filtering information here. Now if we click on this here, got a nice little tutorial on how to do some filtering. Now we're not going to go too deep into this. We might play with it a little bit more as we get more into the state, but of course right now we only have a VPC, so there's not much to do. But let's just take a look at a few simple ways to get some data out of our state. So we start out, we can see that on our top level, we've got version, Terraform version, serial lineage, outputs, resources, just like that. Well, let's just start with resources. So if we do a dot bracket like so, and then quote resources, there we go. So now we have just the resources portion of our state. So after that, what we need to do, because we see a bracket here, that means we've got a list of items. So although there's only one, this indicates that we're going to need to provide an index. So just like so, and that bracket is now gone. Now after that, let's say we want to see some instances. I think you're starting to get the point here. There we go. We got instances, and then if we want, let's say, the cider block, we once again have to provide another index because we have that bracket there. So just like so. So now we have this. Next thing we need is the attributes, just like so. And now let's say we want the cider block, just like so. Not a whole lot going on there. Pretty straightforward. Once again, if you do see a bracket here, you're going to need to make sure you provide an index. Even if there's only one, you'll need to provide index 0, 1, 2, 3, whatever you need. So that's really about all we'll cover right now for the cloud section. Let's go take a look at how to do the same stuff in the console. So let's run a Terraform show. As you can see, things look a little bit different. Terraform show is going to show you your resources and the attributes for those resources. As you can see, it's not in JSON, it's in HCL, so it's a little easier to parse kind of, at first glance. Let's take a look at Terraform state list, we've seen before. There you are. So now state list is just going to show you the resource without any of its information. Show is going to show all of the resources and their information. State list is just going to show the resources. Now if we run Terraform state show, AWS VPC.mtc VPC, just like so. Now, if we had multiple resources, this is going to just show us this resource. So just so you know, Terraform state show, followed by the resource, show you the Terraform show of that resource, whereas Terraform show is going to show you all of the resources. All right, so now let's play with JQ a little bit to show you from features. Show, AWS VPC, output information. State list is just going to show. The resources. Now if we run Terraform state show, AWS VPC.mtc VPC, just like so. Now, if we had multiple resources, this is going to just show us this resource. So just so you know, Terraform state show, followed by the resource, will show you the Terraform show of that resource, whereas Terraform show is going to show you all of the resources. All right, so now let's play with JQ a little bit. And if you haven't installed it, that's sudo apt install JQ, which I already have. So just make sure you run that if you don't have it. So if we do Terraform show-json pipe JQ, as you can see, this is the JSON formatted version of Terraform show. So now let's see how to get to some of these attributes using JQ. As you can see, it starts with values, root module, and then resources. So let's try to get a hold of this CIDR block. So we're going to need to use values, root module, resources, values, once again, and then CIDR block. And of course, keep an eye on this here. We've got a bracket right after resources, so we're going to need to use an index. So let's bring called it back by the resource.
Dah, ini kenapa lagi error gini?
Show you the Terraform show of that resource, whereas Terraform show is going to show you all of the resources. All right, so now let's play with JQ a little bit. And if you haven't installed it, that's sudo apt install JQ, which I already have. So just make sure you run that if you don't have it. So if we do Terraform show-json pipe JQ, as you can see, this is the JSON formatted version of Terraform show. So now let's see how to get to some of these attributes using JQ. As you can see, it starts with values, root module, and then resources. So let's try to get a hold of this CIDR block. So we're going to need to use values, root module, resources, values, once again, and then CIDR block. And of course, keep an eye on this here. We've got a bracket right after resources, so we're going to need to use an index. So let's bring this up some. It looks like we're not going to be able to fit it all, but it's pretty close. So what I want to do is do a Terraform show-json pipe JQ. Then what we're going to do is do a dot values, which is the first item we want, values. Then we're going to do dot root module, just like so. Then we do dot resources right here, and then we need to provide our index. We want the first resource here, just like so. And then we get values from that right here, and then we just provide CIDR block as the last argument here, just like so. And we hit enter. There we are. We now have it. Now, there are times where you may be using this in automation and you don't want that wrapped in quotes. So if that's the case, just pop over here right behind the JQ and add a -r, just like so. All right, so we've taken a look at some basic ways to filter through our state from within our Terraform Cloud Console and also from within our Cloud9 console. So go ahead and mark this lesson complete. Come on back to the next one and let's get building some more infrastructure. Hello and welcome back. In this lesson, we're going to make our deployment a little more dynamic by adding variables. Now, variables, just like any other programming language, basically holds the value of something that you want to use in potentially multiple places. So let's go ahead and head over to our VPC, and let's just cut this out. We'll Control X there, and I'm going to add var.vpc_CIDR in its place. So now, as you know, with a variable, this needs to be defined. Now, you can define variables anywhere you want in the deployment for the most part. I could just stick it right up here if I want to. But we're not going to do that. This isn't very clean, and it starts to clutter up our script very quickly as we add several more resources, which we're going to add. So let's create a new file called variables.tf, just like so. Now remember, this is another TF file, which means it will be processed with all of the other TF files, so it doesn't matter where this variable goes, as long as it's in a TF file. I could stick it in providers, backends, whatever. But, of course, variables.tf makes a lot more sense. So let's go ahead and define this variable, or at least initialize it. So I'll add variable, VPC CIDR, then the bare minimum you need is some open and closed braces. This is actually all that's required by Terraform to initialize the variable and know that it needs to ask for it. Now, if you don't have this and you just have var.vpc CIDR, it's of course going to wonder where this variable is defined, and it's going to give you an error. But as long as it's in this variables.tf, here, it will ask you for it at the command line. Let's add one more thing first, just to be polite to anyone who has to follow our code and define these variables, and let's add a type. And since that CIDR is a string, because it has dots, slashes, and numbers, we just define that type as a string. This is not explicitly required, but again, it is pretty polite to have. Alright, so now let's apply this and see how things go. So we'll do a Terraform apply, auto approve, and if I just type 10.123.0.0/16 like so, as you can see, there are no changes because my infrastructure matches. Perfect. That's exactly what we were hoping for, and that's what we should have expected. Okay, so now we see how to define this on the command line. That's not very efficient. It's probably a lot better if we define it somewhere else. Now we have several options here. First up, we have the tf-vars files. So if I create a new file, and let's just call this dev.tf-vars, just like so. What we can do is we can define all of our variables here and have them ready to go. So what we can do is just type vpc CIDR equals 10.123.0.0/. Just like so. And to use this file, we do a Terraform apply var file equals dev.tf-vars and apply. As you can see, we get the same result. No changes. Perfect. But what if we have a production environment that we'd also like to deploy to? Let's try that. Let's do prod.tf-vars, just like so. vpc CIDR equals 10.124.0.0/16, just like so. Let's see what happens whenever we apply this. I'll just replace this dev with prod, just like so. As you can see, we've got a change to make now because it's looking at 124 instead of 123. Sure, that's fine. We can do that. 124. As you can see, we've just replaced this dev with prod, just like so. As you can see, we've got a change to make now because it's looking at 124 instead of 123. Sure, that's fine, we can do that. As you can see, it destroyed our old VPC and now is creating the new one. Alright, great. So that's great. Now what if we don't want to specify that vars file every time? Now if there's only one, we don't have to specify it, but since we have two tf-vars files in there, we need to make sure we specify it if we need to pick one. But there are times where we just, quite frankly, don't care what the VPC is, or we always assume we're going to deploy to dev first. So in that case, we can actually specify a default value. So I can just type default equals 10.123. 0.0/16, and I can run a Terraform apply auto approve. Alright, as you can see, we've got another replacement to make, and it is doing so. Alright, all set. So I think that pretty much gives you a good handle on how variables work within Terraform. There are, of course, a few other little nuances we may encounter along the way. But for this lesson, go ahead and mark it complete. Come on back to the next one, and let's build some more infrastructure. Hello and welcome back. In this lesson, we're going to take a look at how to reference other resources to create certain resources. So what we'll be doing is creating an internet gateway, which of course needs to know which VPC to which it needs to connect. So let's go ahead and get started on that. Now the internet gateway is not super complicated. Of course you can go and check out the docs, they're pretty easy to find, but we're not really going to bother diving in because quite frankly, it's only a few lines we have to deal with. So let's go ahead and do that. So we're going to create a resource, once again, AWS Internet Gateway, surprise, surprise, very easy to memorize that one. And let's just call this the MTC_Internet Gateway. And of course you can use any prefix you want. MTC, of course, more than certified is the name of my course, so that's what I stick to. We're going to open and close some braces there, and here is where we need to specify a VPC ID, just like so. So what we need is we need to somehow pull the ID of this VPC from here. Now, if we head into our state, we'll just hop in through the console, we can see right here, there is an ID that is specified. Now, as you can see, I already had that up, but right here, you can see we are using a resource to filter, first resource, and then we are specifying the instance, then what we need are attributes and ID. So let's take a look at how this looks. as you can see, we've got instance of that, and then we just look at our attributes, ID, just like so. .id. And of course, I can also do a Terraform state show AWS VPC.mtc underscore VPC. And I'll just do pipe rep ID. And there are a lot of things with ID in there, but you can see here, ID, it's a little bit faster and easier to remember than say JQ. This is a quick and dirty way to get the information you need. So as you can see, we've got an ID, and that's what we're going to specify here. So by typing AWS VPC.mtc VPC.id, we are extracting this ID attribute. So I'm going to Control S to save this. We've got our default set variable, so we're not going to have to specify anything. Let's do one more thing and add a tag to this. So I'll just say tags equals name equals mtc underscore igw, just like so. So let's go ahead and run a Terraform plan. Let's make sure everything looks good before we run that apply. Everything looks good. And one really big reason we want to make sure we run plans in certain situations is because there are times where this VPC may have to be destroyed to deploy something new, which of course can become a massive issue in production. So it's always good to run a plan first. And of course, an apply without the auto approve will also run a plan and then just ask for your input on whether to continue or not. But as you see, we've got our VPC ID right here, just as we asked for. So perfect. So let's just go ahead and run out right here.
Oke.
Just as we asked for, so perfect. So let's just go ahead and run our Terraform apply, and I'm going to add auto approve because the plan looks great to me. Okay, beautiful. Resource added. We can come and check out our state now. As you can see, we've got a lot of states here, or state updates rather, and this is our new state. We've got all sorts of little changes here, but as you can see now, we've got more resources. We now have our internet gateway and our VPC. And if I do a Terraform state list, all is well. All right, so that's all for this lesson. Go ahead and mark it complete. Come on back to the next one, and let's continue building our deployment. Hello and welcome back. In this lesson, we're going to take a look at one of the issues that you're going to encounter a lot in DevOps. Now, as we know, we want all of our stuff that we deploy basically to be able to be replaced at any given time. Also, we want to make sure that whenever we want to deploy something else, we don't ever encounter conflicts or anything like that. Now, there's one thing here already that can cause some conflicts, and that is the name of our VPC in IGW. Now, it's not really a huge deal, as AWS is fine deploying more VPCs with the same name tag on them, as tags aren't really any concern to AWS, but to us, we want to ensure that we know the difference between this VPC and another VPC that we create. Now, to do that, we can use the random ID resource. And again, you're going to be using this a lot for all sorts of resources, EC2, load balancers, all of those things. You're going to need these random IDs. Now, there's also a random password resource. There is a UUID. There are a lot of great resources here that you can use whenever you need to create something that requires entropy. So let's take a look here. As you can see, we've got a few things that it mentions here, a few options. Now, the one we're going to focus on right now is byte length. This basically just tells us how long the number or string is going to be in bytes. Now, we've got our outputs here. As you can see, read-only, we've got ID and DEC. Either one of these will work for us, but we'll probably go ahead and use DEC. And then you've also got keepers and a prefix. We're not going to use either of those yet, but keepers might show up a little bit later. So let's go ahead and get started. So what we want to do, and I'm going to put this up at the top to make it easy to find, we're going to create a resource, random ID, just like so, and we will just call that random. Make it very simple, and open and close our braces once again, and we're just going to give it a byte length of 2, just like so. So now that we've done that, we need to add this random ID to our tag. Now to do that, we're going to use a syntax called interpolation syntax. And what this will allow us to do is to concatenate this random ID to our strings without having to use the concat function or anything like that. There are a lot of ways to do this. Some of them could be more appropriate in some situations, but right now, this is the right move for us as it's the simplest and easiest to read. So I'm just going to add a little dash there, and to kick off our interpolation, we're going to use a $sign followed by a brace, and then we're just going to access that random ID dot random. As you can see, ID, generated ID presented in basic.
Kalau yang oops, sorry, gimana sih cara biar nge-override AWS Terraform? Gue nggak bisa ngapalin satu-satu anjir. Nah ini autocomplete nih. Tapi gini, apa namanya? Ininya mati lagi. Tuh, gimana sih? Syntax highlightingnya tapi mati. Coba jawab ini deh. Kayak hasil code Terraform. Coba. Terraform syntax. Terraform syntax. Nggak betul. Ya ini gini. Gue butuh ini ya dong. Oke. Misalkan gitu ya. Tuh, kamu lagi nih. Apa ya? Error line. Ya udah di situ aja. Disable dulu. Loading lagi lama banget. Resource random. Loh, asal lagi. Random. Ya gini kayak gitu.
As you can see, generated ID presented in base 64 without additional transformations or prefix. There's actually a chance you may want to use a prefix. So we're going to use the decimal point, just like so. And then we'll do the same down here for our IDW. Random.id.random.dec, just like so. All right, so now let's run our Terraform apply and see what happens. You're going to see we're actually missing something. So I wanted to call this out and point it out. Could not load plugin. Because we've added a new resource from a different provider, random ID. Random is a different provider. Just like AWS is a provider, random is also a provider. So we need to run another Terraform init. Okay, all set. As you can see, installing HashiCorp random. Just
IGW.
like so. And then also, we need to make sure we type things properly. That's an underscore, not a dot. So now let's run Terraform apply. All right, as you can see, we've got our random here. Let's head into our state and see what we've got. States and our newest state here. Tags MTC IGW 63453. That is perfectly fine. And for the VPC, let's check out our tags 63453. All right, so now if we were to deploy another VPC, we could very easily tell the difference between if it was our
random must be random must be initiated for every text in the resources and not classes each other. Udah kah? Lama banget.
All right, as you can see, we've got our random here. Let's head into our state and see what we've got. Go back to states, and our newest state here, tags MTC IG.
Terraform states show. Oops, Terraform list. Aduh, apa ya? Terraform states show. Bukan Terraform destroy event login output. State list. Enggak cuma lupa lagi saya.
GW63453, that is perfectly fine. And for the VPC, let's check out our tags, 63453. All right, so now, if we were to deploy another VPC, we can very easily tell the difference between this VPC and the next one we deploy. The odds of having a collision between these decimals is unbelievably slim. That's really all there is for this. Now, we've added some entropy to our deployment so that we ensure that if we're deploying multiple VPCs and multiple resources, we won't have any overlaps and we'll have the ability to filter and find our resources appropriately. So go ahead and mark this lesson complete, come on back to the next one, and we'll continue building.
Oops, mana Terraform workspace? Jadi gimana sih maksudnya? Oh, Terraform Cloud. Oh, itu versioning berarti ya? Oh, ini dia.
Building our infrastructure. Hello and welcome back. In this lesson, we're going to take a look at what can happen when some of these resources end up existing simultaneously with previous resources, which can cause a conflict, which can cause all sorts of havoc within your environment. So let's go ahead and check that out. As you can see, I have my environment applied here. So I'm going to go ahead and clear this screen. And now what I'm going to do is just make a little bit of a change. I'm going to head into my variables here. Let's just change this to 124 instead of 123. Let's do a Terraform apply. Now I'm going to save you any more time here. Obviously, the VPC usually destroys a lot quicker than this. So I'm going to back out of this. This is obviously crashing here. Just going to press Control-C twice just to nuke this whole thing. Now if I go back into my console, my AWS console, I'm just going to go to the dashboard, services, and VPC. As you can see, we have our VPC here. So the reason why it's not being able to delete is it's trying to create a new one, and the internet gateway is actually fighting for access to the new VPC, and it refuses to allow this one to be deleted. So let's see what happens if we create a lifecycle policy that will actually fix that. And I know this may not make a whole lot of sense. I'll be sure to add a few extra resources to help explain exactly how this is working. But once you see it, it will help you understand. So what I'm going to do is hop into the VPC area, and we're going to add a lifecycle. Lifecycle, create before destroy equals true. So basically what we're doing is we are giving this internet gateway another place to go before we delete this VPC. So what we want to do is we want to create the new VPC before this one's destroyed, which will allow a seamless transition for this internet gateway. So let's see what happens now. If I do a terraform apply approved, all right, as you can see, the new VPC is created first. Then the internet gateway has been modified. So what's happening is this gateway isn't being destroyed first. It's just being modified to connect to the new VPC, and then the old VPC is destroyed. So that's what's actually happening and what caused the issue. Now before, as you can see, the VPC must be replaced, which we knew. One to add, one to change, and one to destroy. So the gateway is not being destroyed. Only the VPC has to be destroyed because we changed the CIDR block. So since the CIDR block was changed, VPC has to be changed, which means it has to be destroyed and recreated, whereas the internet gateway does not have to be.
Bagus banget nih.
Now before, this gateway isn't being destroyed first. It's just being modified to connect to the new VPC, and then the old VPC is destroyed. So that's what's actually happening and what caused the issue. Now before, as you can see, the VPC must be replaced, which we knew. One to add, one to change, and one to destroy. So the gateway is not being destroyed. Only the VPC has to be destroyed because we changed the CIDR block. So since the CIDR block was changed, VPC has to be changed, which means it has to be destroyed and recreated, whereas the internet gateway does not have to be destroyed. It just needs to be relinked to the new VPC. Now because this new VPC didn't exist yet, Internet Gateway didn't have anywhere to go, and Terraform refused to destroy it whenever all it was supposed to do was just move it. So what we did was we created the VPC first, the new one with the new CIDR block, then moved the Internet Gateway and modified it to connect to the new VPC, and then destroyed the old one. So now everything works just the way it's supposed to. As you can see, we still have the same ID for our VPC and the same for the Internet Gateway. The difference, of course, being that the CIDR block is different. It is now 10.124. So you could have potentially changed this random ID using something called keepers, but we may look into that later. We're not going to bother that now. Right now, the best way to do this is this create before destroy lifecycle policy there, as indicated within the random ID docs, this resource. Used in conjunction with resources that have the create before destroy lifecycle flag to avoid conflicts. So again, I know this one was a little bit complicated, but this create before destroy, keep that in the back of your mind. It's probably going to pull you out of some very difficult situations in the future.
Punya taring, nggak punya cakar, rokok takut. Ups. Jadi intinya itu ya, ngebuat dulu resource yang baru ditempelin, terus baru yang lamanya dihancurin gitu. Jadi nggak konflik.
Have the same ID for our VPC and the same for the Internet Gateway. The difference, of course, being that the CIDR block is different. It is now 10.124. So you could have
create destroy historicals true. Oke, ini tuh berarti udahlah, kayak gini aja. Hashtag aja. Hashtag kamu harus tahu. Just like its name, before the following resources disappeared, it will create new one first. Tips for avoid havoc or conflict
from old as the old ones pair to the new ones.
Could have potentially changed this random ID using something called keepers, but we may look into that later. We're not going to bother that now. Right now, the best way to do this is this create before destroy lifecycle policy there, as indicated within the random ID docs. This resource can be used in conjunction with resources that have the create before destroy lifecycle flag to avoid conflicts. So again, I know this one was a little bit complicated, but this create before destroy, keep that in the back of your mind. That's probably going to pull you out of some very difficult situations in the future, and there's a good chance it may come up again. So go ahead and mark this lesson complete. Come on back to the next one, and we're going to start actually adding to this deployment and getting back to the fun stuff. Hello and welcome back.
Oops.
In this lesson, we're going to create a public route table and create a default route in order to send traffic to our internet gateway. We're not going to encounter any new stuff here, so this will be a good review of what we've learned already. So let's get started. All right, first of all, we need to add our route table. So let's take a look at the docs as we typically like to do first. So the resource is called AWS_route_table. Now take a look here. There actually is a standalone route resource, which is what we're going to use. And you can also specify routes in line with the route table. Now, I usually prefer to use standalone resources whenever I can. Not always, but usually. It just gives us more flexibility in the future. So you'll see other resources that may require you to either define something in line or provide a separate resource. And again, I usually prefer to go with a separate resource. It just provides for a lot more flexibility in case things get a little crazy in the future. So we scroll down here, we can see basically it's AWS route table, we name it as we usually do. And this is that inline route that they were talking about. We instead are going to provide an AWS route resource. So if we scroll up here, we can actually see the AWS route resource here. So I'll click on that. I accidentally had the data source open. That's closed now. So here is the AWS route resource. And as you see, basically we will define the AWS route, we will attach it to our route table, and provide a destination CIDR block, which in our case, since we're going to be sending it out through the internet gateway, will be 0.0.0.0/0. So let's go ahead and get started with this. All right, so we're going to create a resource, AWS route table, just like so. I'm going to call that MTC public RT. Again, this one's going to connect to the internet gateway. So
My public.
we will make sure we know that this is a public resource. For security's sake, you always want to make sure you're very explicit about what's public and private, if possible. So next up, we just attach it to our VPC. And as you remember, we just do AWS VPC dot MTC VPC. And thanks to autocorrect, I could see that that was correct. You can also scroll up, of course. AWS VPC, MTC VPC, just like that. And since it requires the ID, we'll just say .id just as we have before. Now all I'm going to do here is add some tags, or a tag rather, name equals MTC hub, just like that. All right, that's literally all there is for the route table that we need to do now. So now let's create that default route. So another resource.
My
AWS route, and then we'll just name that default route. Open and close our braces at
hilang lagi, aneh banget, sulit banget ini ya. Resource AWS out. Name. Argumennya ada apa aja?
Four. Now we need to specify our route table ID. So that we're obviously just going to pull from right up here, AWS route table .mtc public RT, just like so. And then this also is just an ID. And if you needed to see that, you can actually go AWS route table, scroll down, and you can see under attributes, the ID is one of those attributes. There's also ARN, owner ID, and the ability to access the tags. All right, so once we've done that, we need to provide the destination CIDR block, just like so. And again, that is 0.0.0/0, which allows access to anywhere. So basically anything that comes that is destined for to provide. The ID is one of those attributes. There's also ARN, owner ID, and the ability to access the tags. All right, so once we've done that, we need to provide the destination CIDR block, just like so. And again, that is 0.0.0.0/0, which allows access to anywhere. So basically, anything that comes that is destined for the outside world is going to hit this route table. In fact, anything at all is going to hit this route table because we have no other routes. And then we just need to provide the gateway ID. Now that is going to be our internet gateway. So AWS Internet Gateway, MTC Internet Gateway. Just like so, .c Internet Gateway .id. Once again, it's asking for an ID. You can almost universally assume that's going to be the attribute that you need to satisfy the conditions required. Maybe not always, but I haven't encountered a case yet that doesn't. All right, so that is literally all we have to do here. Let's go ahead and run a plan. Okay, nothing bombed here. That looks good. Looks like it is adding our default route and our route table. So let's go ahead and apply. Not being destroyed. Only the VPC has to be. Alright, 2 added, 0 changed, 0 destroyed. We'll do a Terraform state list to verify. Look at that, we've got our new resources there.
Okay, a route table, default route,
And we head into our states. We can see that we have a new state from a few seconds ago, and if you look at the overview, you'll actually see our new resources here as well. Alright, so everything worked out. That's all there is for this lesson. Go ahead and mark it complete. Come on back to the next one, and let's continue the course.
Dah kan tadi default route table. Kok masih lagi?
Hello and welcome back. In the last lesson, we created a public route table. Now that's great, we of course need to get to the internet sometimes, but we don't want resources defaulting to that if it's not explicitly selected. If we had every resource defaulting to the public route table, that could lead to some serious security concerns. So we're going to, quote, create, end quote, a default route table. And you'll see why I just put quotes around that in just a second. So let's get started. Alright, so if we take a look at the AWS default route table docs, we can see that this is an advanced, ooh scary, resource with special caveats. It's not really that scary. But basically what's happening is Terraform isn't creating this, it's basically importing it without using the import command and adopting the route table that is already there, created for that VPC. So this simplifies a lot of the work that we would normally have to do to create a route table, make it the main association and all this. We're basically just saying, hey, you know that default route table that you've already built? Use it. So that makes things a lot easier for us. As you can see, it's very similar to the existing route table that we've already created, but basically all we have to do is access the VPC default route table ID that already exists, like you see this. So we don't actually create this. This is something that the VPC already has as an attribute. So let's go take a look. So we hop into our VPC here resource and look at the arguments and the attributes. If we scroll down in the attributes, you can actually see default route table ID. So the ID of the route table created by default on VPC creation. So that's all we need to access. We don't have to create this route table at all. So let's go ahead and do that. So we just need to create our resource, AWS default route table, and then MTC, and we'll just call that our private route table, just to indicate that it is in fact private. And then all we have to do is default route table ID equals AWS VPC.MTC VPC.default route table ID. That's literally it. That's all we have to do. Now we still want to add some tags here, just as always. So let's do that. Tags equals name equals MTC underscore private. Just like so. And that's it. Let's go ahead and run our Terraform plan and make sure nothing explodes.
my private RT.
Float. All right, looking like all green. We've got one to add, which is, of course, our default route table here. So let's go ahead and run our Terraform apply. Auto approve. All right, apply complete. Resources added. Let's go and verify that everything looks good here. First, I'll just hop in here. We'll take a look at our resources. All right, MTC private route table. So that is there. We'll take a look here and look at our route tables. As you can see, our MTC private route table is here now. And the route has no route except to the VPC, so that is private. If we look at
Terraform auto complete. Apply. Bararam barap pam 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 barararam.
Oh, gue di kedua.
North California. Di route table, sorry. Internet. Okay.
in our public, you can see our route has our public route to our internet gateway. So congratulations, you have created your default route table now. Go ahead and mark this lesson. Hello and welcome back.
Berapa aja nih ya? Iya tuh 1,5 juta.
In this lesson, we're going to start working towards creating our subnets, but before we can do that, we have to be able to specify the availability zones which we can use. Now, as you may or may not know, every AWS region does not have the same number of availability zones, and that number can also change. One zone may have A through D, another one may only have A and B, and this can get very aggravating when building your infrastructure. Luckily, Terraform has a way to help. By using what's called data sources, Terraform is able to query resources within AWS in order to ensure you have the information needed to deploy. So let's take a look at the AWS availability zone resource. Take a look here at the docs. As you can see, basically you're going to specify not a resource, but data. So this is different than what we've been doing so far. Now, as you can see on the left, I'm in the data sources section, where all of these up here are resources. These are the data sources you can use. You've got availability zones, you've got caller identities, you've got tags, you've got IP ranges. There's a lot of really cool things you can use here that could be very, very helpful. Now, there are also data sources within your resources, as you can see here. And what this allows you to do is query all of these existing resources that may have been created either by another Terraform deployment, CloudFormation, or manually, hopefully not. But this will allow you to access the information you need from these resources without having to deploy them in this same deployment. So these data sources are basically AWS Universal. So let's go ahead and start playing with these availability zone resources. First up, let's take a look at the API itself from the command line, and let's see what type of information gets returned there. So if I do AWS EC2 describe availability zones, just like so, and specify region, US East 1, we can see we've got a lot of availability zones here. We've actually got A through F. A, B, availability zone, S, E.
AWS EC2 describe availability zones region
East 1, we can
is 1. Nanti belum di setup ya.
We can see we've got a lot of availability zones here. We've actually got A through F. A, B, C, D, E, and F. Let's take a look at another region. Let's take a look at West 1. Oh, well, that's a lot worse. Now, again, what you see on my screen may not be what actually you see on yours, depending on the day that you run this. Sometimes these availability zones will go down. As you can see here, we've actually only got a B and a C here. So by hard coding these anywhere in our code, we can definitely encounter some
Iyalah,
issues.
benar.
If B goes down and an A comes up in US West 1, all of a sudden specifying US West 1B is going to be a problem in any of your resources. Now, you'll see coming up in the subnets, we have to specify the availability zone, and we're going to look at ways to do that dynamically to ensure we don't have this problem. So what we're going to do first, let's go ahead and add that data source. So data, AWS, availability zones, available. We're just going to name that available, and that's fine. And then all we need to do here, we're not going to specify any other information, is we're just going to open and close some brackets. You can provide filters and things like that. So if you had, for instance, local zones, you can filter by opted in or not opted in. But that's not something we're going to encounter in this course.
That's not.
So let's head back up. Once we've done that, we're going to go and play with a cool new tool called the Terraform console. So go ahead and apply this. Console requires that this information is in state for it to be able to access it. Okay, apply complete, which is perfectly fine. There's nothing that should have changed unless, of course, you had destroyed before this, which is perfectly fine. Now let's run the command Terraform console. All right, once you get this little signal here, you are in. So within the Terraform console, we can run just about any command and access any resource within our Terraform deployment. That also includes running certain functions and other things that you may need to use to test different types of outputs and things. We're going to probably use this a good bit coming up. But what we want to do now is we want to access these availability zones. So let's just go data.aws, availability zones, .available, just like that, and hit enter. All right, as you can see, we've got our availability zones here. And since I am in US West 1, I've only got B and C, which is, again, exactly what we saw before. And as you can see, we've got a names attribute here. There's an ID for the region, and then names is what we're going to end up wanting. So if I press up and type .names, we now have a list of just our names. Now, since it's a list and it is in a bracket, that means we can use indexes to access those. So since indexes start at 0, at least proper ones do, we add that index, and we get US West 1B. Now we go back and add the index of 1, we get US West 1C. Now another cool thing, as I mentioned, is you can also test out functions. Now Terraform has a link function, so we use link data AWS availability zones.available.names, just like so, hit enter. We get 2. So as you can see, there's a lot of possibilities here to ensure that we deploy just the right number of resources based on the number of availability zones that we have available. So go ahead and keep that information in the back of your mind. Mark this
Resource AWS. Nggak ada availability zone. Nggak ada di sini. Ada banget aja. Resource AWS AV lah availability zone. Air ini rawan ini banget, rawan typo. Availability OS availability zones kosong. Oke. Kami loh kok encounter issue ini banyak banget. Oke. Kami boycott Indonesia, manusia Pancasila, Satyaku Dharmakan, Dharmaku ku baktikan, agar jaya dustak Indonesia. Loh kok nggak bisa? Oh data cowok, data malu-maluin cok. Availability zones, nah ini dia, mantap. Availability availability.
Ups. Upsi. Hahaha. So suci. Hahaha. Gue bukan. Dulu sahabat, sekarang jadi babat. Pakai handuk dong. Internet lama banget anjir. Oke, no changing. Terraform state, node state, apply, auto.
That you may need to use to test different types of outputs and things. We're going to probably use this a good bit coming up. But what we want to do now is we want to access these availability zones. So let's just go to beta.aws availability zones .available, just like that, and hit enter.
Kok availability ya? Available. Available. Oh, berarti kayak git push, git add, terus git commit gitu ya. Terraform console. Data AWS availability zones dot available. Oke, kita cuman punya US USA. Oh, oke. Cuma punya 2 easy.
Alright, as you can see, we've got
BNC. Oh, beda ya? Oh, beda. Ya, nggak
Nice.
masalah juga.
our availability zones here. And since I am in US West 1, I've only got B and C, which is, again, exactly what we saw before. And as you can see, we've got a names attribute here. There's an ID for the region, and then names is what we're going to end up wanting. So if I press up and type .names, we now have a list of just our names. Now, since it's a list and it is in a bracket, that means we can use indexes to access those. So since indexes start at 0, as proper ones do, we add the index, and we get US West 1B. If we go back and add the index of 1, we get US West 1C. Now, another cool thing, as I mentioned, is you can also test out functions. Now, Terraform has a link function, so if we use link data.aws availability zones.available.names, just like so, and hit enter, we get 2. So as you can see, there's a lot of possibilities here to ensure that we deploy just the right number of resources based on the number of availability zones that we have available. So go ahead and keep that information in the back of your
Alhamdulillah.
mind. Mark this lesson complete. Come on back to the next one and let's start building our subnet. Hello and welcome back. In this lesson, we're going to start building our subnets so our future EC2 instances have a place to stretch their proverbial legs and get some network connectivity. The subnet creation is going to span over a few different lessons as we're going to iterate over the attributes in order to ensure they're as flexible as possible for future deployment expansion. So we're going to start simple, then iterate and add on each piece until we have a nice robust set of infrastructure that can expand as we need it. So let's get started. First of all, if you haven't exited your Terraform console, luckily it's nowhere near as difficult to get out of as Vim is. We just need to type exit to do so. Alright, and now that we've done that, let's take a look at the AWS subnet docs. As you can see, not too difficult here. Of course, there are certainly some other attributes that we'll want to utilize, such as specifying our availability zone. We might also want to use map public IP on launch for the public subnets, which of course makes sense. So let's go ahead and start coding this out. Again, we're going to do it very simply at first, and then we'll start to...
10.1.3 tuh apa namanya, shader block beda-beda. Shader block berarti tuh dia apa bedanya ya shader block dan subnet? Side block, what is difference between shader block and subnet? Oh, nggak deng, ya Allah, nggak. Shader itu kan teknik itu, men. Teknik subnetting anjir, ya Allah. Lupa gini.
break it down a little bit and make it more dynamic so we don't have to provide so much hard-coded information. Alright, I'm just going to hop down to the bottom of my main.tf here. Let's give us a little more room. There we go. And we're going to define a resource, AWS subnet. Once we've done that, we'll just name this mtc underscore public underscore subnet, just like so. And then we need to specify our VPC ID, and that of course is AWS VPC dot mtc underscore VPC dot ID. Now you may have noticed that this has been doing some nice auto completion for me, just like so. What this is doing is pulling from the document itself. It's not actually pulling from any other API or any other plugin. This is actually just pulling from things I've already typed. So most IDEs should have this, but if you're in Cloud9, you certainly do. All right, and after that, let's specify our CIDR block, and that equals, we're just going to name this var.public CIDRs, and then map public IP on launch equals true. Since this is a public subnet, we do want any instances deployed within the subnet to have a public IP. And then we need our availability zone. And that equals data.aws availability zones, as you remember, .names, remember we did that within the console. And then we're just going to access the first one, since right now we're only going to deploy one subnet. Don't worry, that's going to change. Right now we're only, and then we're just going to access the first one, since right now we're only going to deploy one subnet. Don't worry, that's going to change very soon, because obviously we need to use more than one subnet to ensure our deployment is resilient. So once we've done that, let's just add some tags, and we'll do a name equals mtc public, just like so. All right, I'll save that file, and of course, since we still have our public CIDRs undefined, we need to go and define that. And variables, variable, public CIDRs, type, we're just going to say string right now, but this is going to change very soon. Variable, net.
My public subnet variables variabel tadi namanya tuh apa dia public CIDR.
Variables, variable, public, CIDRs, type. Well, we're just going to say string right now, but this is going to change very soon. So right now, let's just keep it very simple, 10.124, and we're just going to say 1.0/24. So we'll be using a /24 range for all of our CIDRs in our subnets. So I'll go ahead and save that. Go back, everything looks good. var.public CIDRs, did I name that right? Public CIDRs, yes I did. Perfect. So everything looks good. Let's go ahead and just make sure that everything is in fact good. So let's make sure that everything else looks good. Actually, looks like I'm missing something right here.
Aduh, sorry. Connect to Terraform Cloud. Exit Terraform plan.
Here, as you remember, this is data.aws availability zone.available.names. You need to keep that in mind.
Gundul, kacodol.
On a Terraform plan. All right, looking good so far. Okay, one to add, MTC public. We've got our CIDR block there, perfect. Availability zone, US West 1B, which is perfect. That was the first one. If you remember, I had B and C available. So, since we're using that first one, we get to have it here for this.
Okay.
So let's go ahead and run this apply. Terraform apply, auto approve. All right, perfect. One added, zero changed, zero destroyed. We head over to our resources and I give it a little refresh. As you can see here, available, that's actually the list of availability zones. And we've got our MTC public subnet right here, all ready to go. All right, perfect. So go ahead and mark this lesson complete. Come on back to the next one, and we're going to take a look at how to subnet. This one, the ability zone, and run this apply. Apply.
Iyalah, jadi nambah gitu. Ini 1 2 4 aja. Iya benar. Iya benar. Ininya kan gak berubah ya. Kenapa itu public shader berubah anjir? Ya my bad. Di langit.
Public CIDRs, yes I did. Perfect. So everything looks good. Let's go ahead and just make sure that everything is in fact good. So let's make sure this is data.aws availability zone.available. Names need to keep. All right, looking good so far. Okay, one to add, MTC public. We've got our CIDR block there, perfect. Availability zone, US West 1B, which is perfect. That was the first one. If you remember, I had B and C available. So since we're using that first one, we get to have it here for this subnet. So let's go ahead and run this apply. Terraform apply, auto approve. All right, perfect. 1 added, 0 changed, 0 destroyed. We head over the list. So go ahead and mark this lesson complete.
Oke, break dulu. Lah, drawing. React sampai 2.15. Telat. My bad. Ya sejam lah. Let's go.
Come on back to the next one, and we're gonna
Count. What is count? Why do we need count?
Hello and welcome back. In this lesson, we're going to take this hard-coded subnet we created using this hard-coded variable, and we're going to make it a little more dynamic, and we're going to allow us to create multiple subnets without having to just say copy and paste like this. So this is how someone without Terraform skills would do something. They would just create 2 resources like this. This is not dry, which means do not repeat yourself. This is kind of cluttered and just not clean. Now, there are times where you might just say, you know what, this deployment is ephemeral, why not just have 2 resources, who cares? But in the long run, when keeping clean code, this is something you'll want to try to avoid as best you can while still getting the job done. So what we're going to use is the count meta argument up here. Now, as you can see, there's count and there's for each. There are a lot of ways you're going to find to do a lot of things. Terraform has been around for a pretty good amount of time now. So it's changed a lot over the years, and some of the ways I do things may change, and you may find that some ways click better than others. But just know there are lots of ways to do things, and that is perfectly fine. As long as it works in most cases, you're going to be fine. There's a good bit of information here to kind of help you understand what makes the most sense. So let's get started. So what I want to do here is, first of all, I'm going to head into my variables, and we're going to add another cider. Remember, we have 2 availability zones to work with, so we might as well create 2 public subnets. So what I'm going to do is just add a bracket there, and we'll add another subnet. I'll just do that 3.0, just like so, and then
Oke. Oops. Shout out to all this guy.
of course we need to change this to a list of strings, just like so. Basically, this is saying that there's going to be a lot of strings within this list. All right, perfect. So now we have 2 of these, and as you know, to access these elements, we're going to need to access an index. So first of all, we're going to set our count equals 2. We want 2 of these now. We've specified 2 ciders, so I want 2 subnets. So we're just going to add this count parameter here. This can go on any resource. This is not specific to the subnet resource, and we want 2 of them. But now, how do we know how to access which cider for which deployment of the subnet? All we do is add count.index. And what this does is each time it loops to create a subnet, it counts up. So the first time it creates a subnet, the index will be 0, and then the second subnet it creates will create an index of 1. So this here automatically chooses the proper item from this list. So now what we need to do is do exactly the same for our availability zone name. So just add count.index there, just like so. And then the one more thing
Oh,
we're
berarti
gonna do
ntar
here is
bikin
we're
dua
actually
ya?
going to modify our name tag
Random.
to also include that
Count dari
count.index.
index.
But I'm going to start these at 1 instead of 0. Since they're human readable
Iya, betul,
tags,
betul,
it might make
betul,
more
betul.
sense to finance if everything starts at 1 instead of 0. So we're going to tag them as
Ah,
mtc public
iya, iya. Berarti
count.index
nanti,
plus.
damn, keren banget ini. Iya, paham, paham. Paham, 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 paham. Berarti di sini nanti dia count.index. Oke. Habis itu di my public subnet dia juga gitu. Ups. Minus dolar. Oh, dolarnya mana? Nah, ini count.index plus 1.
1. So we'll be running this arithmetic here within this interpolation. So count.index
Okay,
will be 0
okay.
plus 1. The first MTC public will be 1, and the second will be 2. All right.
Because VPC have to value of subnets.
Alright, so that's about all we've got there. Let's save that file. Make sure everything looks right here. And let's try a plan real quick. Alright, we've got 1 to add and 1 to change. So basically what's happening is we've got to change one of the subnets to get the right count, and then we've got the new subnet here. So we've got MTC public 1, which of course before was
Problems.
MTC public, it will be renamed.
Missing key equals to 85 watts. Oh, I know, $61. Oh. Lainnya gue seperti ini. Oh, nggak bisa pakai. Kingslayer. Na, 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 na. For public ciders is a list of strings. Lah iya dong bener. Ding ding ding, ada sepeda.
And then the new one will be count. So we'll be right up at the
Public string.
these parentheses. And as you know,
Loh, kok tiba-tiba ini shader block terraform plan udah bener ah menurut gua. For public shaders. Oh, ini typo nih. Loh, enggak tapi nggak jelas banget anjir. Kenapa?
oh, to access these elements, we're going to need to access an index. So first of all, we're going to set our count equals 2. We want 2 of these now. We've specified
Yang drop
2 CIDRs. So I want 2 subnets. So we're just going to add this count parameter here. This can go on
Count
any resource.
two.
This is not specific to the subnet
count
resource.
count
And we want 2 of them. But
count
now,
two.
how do we know how to access which CIDR for which deployment of the subnet? All we do is add count.index. And what this does is each
Oh,
time it
okay,
moves to
my
create a
bad, my
subnet,
bad,
it counts
my
up.
bad.
So and then the second subnet it creates will
Iya. Ini.
create an index of 1. So this here automatically chooses the proper item from this list. So now what we need to do is do exactly the same for our availability zone names. So just add count.index there, just like so. And then the one more thing we're going to do here is we're actually going to modify our name tag to also include that count.index. But I'm going to start these at 1 instead of at 0. Since they're human readable tags, it might make more sense to finance if everything starts at 1 instead of 0. So we're going to tag them as mtc public count.index plus 1. So we'll be running this arithmetic here within this interpolation. So count.index will be 0 plus 1. The first mtc public will be 1, and the second will be 2. All right, so that's about all we've got there. Let's save that file. Make sure everything looks right here, and let's try a plan real quick. All right, we've got 1 to add and 1 to change. So basically what's happening is we've got to change one of the subnets to get the right count, and then we've got the new subnet here. So we've got mtc public 1, which of course before was mtc public.
Oh, kok gua nggak ada ya? Oh, iya. Oh iya benar, my public subnet 2, my public. Okay.
It will be renamed, and then the new one will be named mtc public 2. Now the IP address for mtc public 1 is going to stay the same as it was 10.124.1.0, but as you can see, we've got the second one here, which is using US West 1C, where the first one was using 1B. So that's perfect. That's exactly what we're looking for. So let's go ahead and do a Terraform apply. Make sure everything goes off without a hitch. All right, awesome. 1 added, 1 changed. Let's go and check our resources here. We've got mtc public subnet, as you can see, index 0 and index 1. So these indices are specified within these boxes here. And then if we head over to our VPC, let's take a look at our subnets, mtc public 1 and 2, and the IP addresses are proper, and we've used both availability zones.
Oh belum. Loh, mana?
So, perfect. And we've used both, and look at our subnets, or these boxes here.
MTC public. Okay.
And then if we head over to our VPC, let's take a look at our subnets, mtc public 1 and 2, and the IP addresses are proper, and we've used both availability zones. So, perfect. That's great. Everything worked out really well. Let's do one really quick thing. So we've manually specified a count of 2 here, whereas we also have to specify 2 CIDR addresses. Having to maintain that connection is not something you want to do manually. You don't want to say, all right, well, we have 2 CIDRs here, we need to make sure we have a count of 2, or we have 3 here, we need to make sure we have a count of 3. Having to maintain that connection is not good. So what if we just used the length function to find the length of this list and specify it that way? Well, you're in luck, because we can do that. So what we're going to do is provide length var.public CIDRs, just like so.
length var public.
This is the Terraform length function, which is right here. As you can see, it runs like any other function does within any other programming language. So fantastic. Let's go ahead and run this. There shouldn't be any changes. No changes. Perfect. So that means nothing has changed. It's pulling the length from our public
Length.
CIDR blocks here
Length.
and using that to set the count of our subnets. So that's all for this lesson. Come on back to the next one, and we're going to take a look at how to create that private subnet. Might even let you do some of the work yourself. Hello and welcome back. In this Terraform Apply Yourself lesson, I'm going to take a step back from the mic and the console for a bit and give you the chance to create the private subnet. If you want, you can name it MTC Private Subnet. You'll need to create the private CIDRs variable and provide 2 CIDRs with which to create your new subnets. It'll be incredibly similar to the public subnet, so this one should be pretty straightforward, but we'll give you a chance to explore how things work and get your hands a little dirty. So, go ahead, pause the video, knock that out, and come on back whenever you're finished.
Aduh, sabar bos.
All right, how'd you do? So as you can see here, I have created another subnet block, and this one is a private subnet. Now we've got the same count here, only this time we are referencing the private CIDRs instead of the public. So we head back over to our variables.tf. As you can see, I've created a new variable, same type, and I've added two different CIDR blocks. And in this case, I used even numbers instead of odd. So after that, same VPC ID, the CIDR block, of course here, private CIDRs, map public IP on launch. Actually, I accidentally put true here. This is going to be false. We obviously do not need a public IP address on our private instances. The availability zone, exact. Exactly the same, and the tags, of course, we have MTC private instead of MTC public. So that's literally all there is to it. Let me change back into that directory, just like so. Let's bump this up a little bit. Let's make sure everything looks good with the Terraform plan. 2 to add, 0 to change, 0 to destroy. That sounds good. We've got a private subnet here with the proper CIDR block in US West 1C. And then I've got a private subnet here in US West 1B in the proper CIDR block here. All right, perfect. So I'll go ahead and run that apply, just like so. All right, everything is green and good to go. Let's take a look. Refresh here, see my resources. They were at 9. Now they are at 11, which is what we expected. We have our private subnet 0 and private subnet 1. And if I hop back into the AWS console, we have MTC private 2 and MTC private 1 right there. I can, of course, sort by that, make it easier. And everything looks correct. All right, perfect. So that's all we actually had for this super quick lesson. Go ahead and mark this lesson complete. Come on back to the next one, and we'll take a look at how to optimize this even further. Hello and welcome back. In this lesson, we're going to step aside a little bit and take a look at what I would call is a pretty aggravating bug with Terraform. Now, if they've got a reason for this, I honestly don't know what it could be because honestly, it just drives me crazy. So, that being said, hopefully they fix this soon, but there is an interesting issue with the way that the Terraform console is able to access variables within your state. So as you remember, we set all of our variables as defaults, which is cool, and we also have set some TF-vars files. We have a prod and a dev. Now, these TF-vars files is generally where Terraform is going to access variable definitions. Now, the weird thing about Terraform is within the console, you're actually not able to access a lot of these variables just by default. There are actually a few rules you kind of have to follow, well, one in particular, to ensure that you are able to access these variables within the console. So this can be a huge pain in development. Now, in production, you probably won't be using Terraform console, so there's no reason to worry about this. But while we're building this out and learning how to access different functions and use different features of Terraform, the Terraform console is incredibly important. So let's take a look at this issue in a little more depth. So first up, make sure, of course, you have applied your deployment. I'm going to run Terraform console. Now let's try to access some of our variables. We'll say var.vpc CIDR. Known after apply. I don't know about you, but I seem to remember applying this. var.public CIDRs. Known after apply. Okay, so that's a little bit annoying. So there's nothing we can do about that here. Let's take a look at another scenario. What if these defaults just aren't processed at the right time for Terraform console to be able to access it? So let's attempt to apply using the prod.tf-vars file instead, which again, currently only has the VPC CIDR defined in it. Let's attempt to apply using that and see what happens. Now, don't bother following along if you don't want to. We're not going to learn anything particularly. I'm just showing you how this works, and I'll be speeding through it pretty quickly. So it's not super important that you follow along here. So if I do a Terraform apply, auto approve, var file, prod.tfvars. Okay, we're specifying a tfvars file. This should work, right? I go back into my Terraform console after applying, type var.vpc cider. Nope, still known after apply. Super annoying. But now I know before I kind of referenced that the name of these files doesn't matter. Well, apparently for Terraform, it does matter when you're using the console. Terraform is going to default to terraform.tfvars. So if you have multiple tfvars files, if one of them is terraform.tfvars, it's going to default to that. So let's run another Terraform apply. And we're not going to specify tfvars because it's going to default to that, as I said. All right, let's run Terraform console, var.vpc cider. Boom, there it is. So as you can see, pretty annoying. Apparently Terraform console does not have the ability to access other var files. And this is something I found complained about in the forums, and this is something that may end up being fixed. If you do see that it's fixed, please reach out and let me know. But for right now, we're actually going to switch over to start using our terraform.tfvars files instead of the defaults, because this bug will hinder our Terraform console usage throughout the course. All right, so that's all for this quick lecture. Go ahead and mark this lesson complete. We've got a much more exciting thing coming up next. Hello and welcome.
Terraform.tfvars. How could I know?
Come back. In this lesson, we're going to take another step to clean up our deployment and make future iterations a little bit easier and cleaner. So as you can tell, this is somewhat of a really, really long string of letters here. It's kind of annoying to have to type more than once. Now, in future lessons, we're going to be using this again. So to help prevent this repeatability, what we're going to do is create something called a local value. Now you can see that here. And basically, it's kind of like a variable, but the great thing about locals is you can use variables within them. You can also manipulate variables. Now, we're not going to do a whole lot of this, but just know that at times where you need to manipulate a variable whenever you're deploying, you can do that within local values. But the primary use of local values is just to prevent from having to repeat yourself many times throughout a deployment. So let's go ahead and create a local value for this here. So I'm just going to cut this out, we'll control X there, and we're just going to call this AZS, just like so, and we will prefix that with local.azs, and we're going to do the same thing down here, local.azs. Isn't that just absolutely so much cleaner? So now up here at the top,
Local.azs. Aduh.
hop, and sometimes you may create a separate file, but in this case, there's not a huge reason to, as it's still a pretty small setup. Now, if we build on this, we'll move it to a different file, but right now, I think it'll be fine. So let's create our locals block here, open and close braces there, and then just AZS equals, or AZs, availability zones, equals, and paste that in, data.aws underscore availability underscore zones dot available. Names, just like so. Now that we've done that, if we run a Terraform apply, auto approve, we should not be getting any changes. Your infrastructure matches the configuration. Perfect. So now also, let's use our Terraform console and let's take a look and just see what it returns to make sure that everything looks right. So if I type local.azs, there it is, exactly what we asked for. So you can index on that, etc. And you're going to see coming up very soon in the next lesson exactly how much this is going to simplify some of the stuff we have to type. So that's all for this super short lesson. Go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to start the next iteration of our subnets to make them even more maintainable. Since we're basing how many subnets we deploy on how many availability zones we have, how about instead of hard-coding these variables, within our variables.tf file and hard-coding the values, how about we just deploy and generate these subnets based on how many availability zones we have? I know this sounds like a daunting task, as nobody wants to use Terraform's HCL to create the arithmetic necessary to calculate subnets, so I've actually got a better idea. How about we use the CIDR subnet function instead? So here is the CIDR subnet function, and this will actually calculate the subnets for you, which is pretty great, because calculating subnets can be a little bit of a pain. So as you can see, you provide the prefix, which our prefix is going to be the VPC CIDR. You provide the new bits, basically how much we want to extend the prefix by. So if we're going from a /16 to a /24, we would just add 8 new bits. And then we specify the net number, so basically how much to increment that by. We want 10.123.1.0, that's an increase of 1 from 0, or 10.123.2.0, that's an increase of 2. Alright, so let's head into the Terraform console, and I'll show you what I'm talking about, because this may not be making a whole lot of sense, but it will once we actually see it. So if I open the Terraform console, let's go ahead and use our CIDR subnet function. And remember, first we need to pass in the prefix, so 10.124.0.0/16, which is our var.vpc CIDR. We're going to add 8 new bits, so basically turning that into a /24. And then for the network number, we're just going to increase that by 1, right there. So let's take a look. 10.124.1.0. Perfect. That gave us one of our first subnets right there. Let's go ahead and check this out again. 10.124.0.0/16, 8, 2. Perfect. So where might we get this number from? Well, if you remember, we've been using count.index. So that's perfect. So we can actually use count.index there to increment our IP addresses. And of course, we can also use var.vpc_CIDR within the function, and we get the same result. So I think you can kind of see where we're going with this. Now the only thing is in the console, I can't use count.index, but that's fine. So next, how do we prevent our private subnet from colliding with the public subnet? Because obviously they're both going to have the same count.index. Well, since we're basing this whole thing and the number of subnets we're creating on the length of our AZs, we can just use that. If we add this to our private network numbers, then we're going to be sure that they're not going to collide. So what I'll do is I'm just going to add length local.azs plus 1, just like so, which of course that will be count.index. And we just need to make sure we don't add an extra parentheses there. There we go. Perfect. So now it's starting with 3. And if we go 2, it'll go to 4. And that way we know that they're not going to collide. So let's go ahead and move this over to our main.tf. I'm going to exit my console there. So what we want to do for our CIDR block, so I'm just going to delete this. We're going to use CIDR subnet, var.vpc CIDR. We're going to increase by 8. Of course, you could set this as a variable or a local if you want to, but we're not going to bother with that. And then for the public subnets, we're just going to use count.index, just like so. Now for the private, we're just going to do almost the same thing, so I'm just going to copy this. Save us a little bit of typing and possibility for mistakes. And I'm just going to type length local. .azs plus count.index, just like so. Now the other thing we want to do, because we're not going to be using our variables here anymore, let's just go ahead and do a length of our local.azs, just like so. And do the same right here, local.azs. All right, so we're going to get the same count. We're going to generate our subnets based on that count, and we've also cleaned up our script a good bit. Now, there's one thing. Remember, our public subnets were odd and our private subnets were even. That's obviously not going to work anymore. So it is going to need to recreate some of these subnets. But let's go ahead and see what happens. Let's make sure I didn't make any typos first. All right, looking good. 3 to add, 3 to destroy. That makes sense. Again, because we have changed the CIDR blocks, everything is looking good. And we're also starting with 0 now, which is perfectly fine. I don't always like to do that, but it's not really a big deal. So we'll go ahead and run that apply. All right, everything looks like it went well. We can check here for our resources. We had 11 resources. We still have 11. That's perfectly fine. Private, private, public, public. Let's go take a look in our VPC console. Private, private. We've got public, public. So 0 and 1. 2 and 3. No collisions. Everything worked out perfectly. All right. So congratulations. We've got these subnets nice and clean now. Go ahead and mark this lesson complete. Come on back to the next one. Hello and welcome back. Whew, that last one was a doozy. But don't worry, this lesson is going to be pretty straightforward.
Pusing. Doozy apa?
Doozy. Doozy.
Cumbersome.
So there's not a whole lot of math going on in this one. All we need to do now is we need to connect our AWS subnets to their appropriate route tables. And to do that, we use the AWS Route Table Association resource. Now, as you can see, all we need to pass in is a subnet ID and a route table ID, and then we're also going to need to pass in a count so that we can associate it to all of the subnets that are created. So let's go ahead and knock this out. So we'll just do resource, AWS Route Table Association, just like so, and we'll just call this MTC public. And we'll call it a sock. We'll save a few letters there. I've been typing enough today. All right, so for our count, we're just going to use this same old count, length, local.azs, just like so. And then we need to pass in our subnet.
di sini rumah kita. Tapi gue kalau minta lagu yang lain nanti ini lagi.
Now there are actually two different
Apa namanya? Provide versus subnet.
ways that we could specify the subnet ID. I just wanted to show you this other way. This is called the splat syntax. It's a little bit different, and honestly, I kind of prefer just using another way, but this is one way you could do it. That's AWS subnet.mtc public subnet, just like so, and then we use a splat right here, which is what they want to call an asterisk. It's a lot more fun than an asterisk, honestly. So call it a splat.id, and then we specify count.index. And kind of what it's saying is all of the public subnets that have been created, put those in a list, and then pull the index out of that list. Now that's going to work just the same as if we were to add count.index right here, .id. And then the last thing we need to do is just specify the route table ID, AWS route table.mtc public rt.id, of course. Remember, ID, probably looking for that ID. All right, so that's actually all there is to it. But wait, you might be wondering, why am I not creating one for the private subnet? Well, remember when I said it would be nice and easy to create a default route table? Well, all private subnets are going to fall back to this default route table by default, so we don't need to worry about creating
my public associate. Oke, yang pertama itu kita initiate ini dulu. Pengulangan count. Dah, count udah. Subnet ID. Count data index. Oh, oke, iya.
explicit associations. So that's great. So this is really all we've got to do. So let's go ahead and run our Terraform plan and make sure I didn't mistype anything. All right, 2 to add, 0 to change, 0 to destroy. We've got our 2 route table associations. As you can see, our subnet IDs are both different, so it is reaching out to both of our different subnets. All right, perfect. So let's go ahead and run our Terraform apply, auto approve, and we'll make sure everything works well. All right, everything seems to have gone well. Let's hop into our resources here. We should be up to about
itu bisa nggak sih? Coba. Ari kok
Yep, there we are. Resources 13, not 11. We've got our 2 public associations. And of course, if we go into here, we can click on the route tables. If I can find them, route tables.
2.
Click on public, subnet associations. Here we are. We can see our 2 explicit associations, public 1, public 2, and then these 2 are associated with the main route table, which actually is our private. As you can see here, main is yes. This, of course, is for the default VPC for this region, which we're not using. So this one is the main. Let's go to subnet associations. As you can see, they're without explicit associations, so that means they are associated with the main route table. All right, perfect. So everything looks good to go there. Go ahead and mark this lesson complete. Come on back to the next one.
Route table kan. Route. Oh, ini dia. My public route. Loh kok subnet without explicit association-nya gitu sih. Apa yang salah? Kok subnetnya ini? Oh. DevOps in the cloud. Ini tuh terus ini gunanya buat apa anjir? Subnet with explicit association. Ah shit, males banget. Coba dari public RT. Okay, root. Resource address RT. Our route table MTC. Public RT. Route table.
explicit associations, so that means they are associated with.
Ini enggak nih, di sini enggak. Privat. Enggak, ya di sini enggak. Di sini dua-duanya nyangkut di sini. Oh, ada titiknya ya?
Roy,
Enggak. Oh, bisa. Lang lokal EZS. Public associate. A public subnet, our subnet, my public subnet, my private default root-nya coba.
it didn't.
Default root. Diam dulu lah. Pilih man. Enjoy. My eyes become large and oh, berarti tadi belum terraform apply gitu. Tapi public associate itu udah ada. Oh, belum ya?
Mistype anything?
Count tab index. Oh iya belum masukin ya. Gimana sih ya? Kayak sate bo. Berubah ya bisa. Bismillahirrahmanirrahim. Dinyatakan 10 jadi 9. Oke. Iya benar berarti itu. Tadi belum. Kampret. As usual anjir. Oke. Oh iya benar. Damn.
All right, 2 to add, 0 to change, 0 to rules. If I can find them, route tables, click on public, subnet associations. Here we are, we can see our 2 explicit associations, public 1, public 2, and then these 2 are associated with the main route table, which actually is our private. As you can see here, main is yes. This, of course, is for the default VPC for this region, which we're not using. So this one is the main. Let's go to subnet associations. As you can see, they're without explicit associations, so that means they are associated with the main route table. All right, perfect. So everything looks good to go there. Go ahead and mark this lesson complete. Come on back to the next one, and we'll start work. Hello, and welcome back. We are finally almost done with our VPC resources, but before we can move on to our EC2 resources, we of course need to add just a little bit of security. So let's do that. We want to make sure that we have access to the EC2 instances we create, and those public EC2 instances have access outbound as well. So let's go ahead and just set up a security group that will give us all access to our resources. So as you can see, we've got a resource, AWS security group, and just like we've seen with other resources we've created, you can either specify the rules inline or you can specify them separately. So this is an inline example here. Everything's within these braces. Or you can specify the rules separately. Now make sure you don't do both. You have to choose one or the other. I think that the best way to do this is going to be to keep consistency and specify them as separate resources. So let's go ahead and get started on that. First thing we need to do is create the base security group. So resource, AWS, security group, and we'll just call that MTC SG, just like so, not to be confused with the guitar. And after that, we will specify a name that equals public SG. As you can see, this isn't exactly a tag. We are specifying a name for the security group that Amazon is going to know about. Now we need to provide a description. So security group for public instances. We'll just call it that for right now. And we may change things around a little bit as we move through this deployment. Things change all the time. And then we just need to provide a VPC ID. That will be AWS VPC.mtc VPC.id as it is every single time we've used it. All right, and next up, we need to create a security group rule, and that will be resource, AWS security group rule, just like so. And we'll just call this ingress all, since we're going to allow any of the subnets
ingress to inbound, allowing semua itu masuk ya. Oh, astagfirullah. Oke, apa lagi lah, tidur dulu.
that are provided within the CyberBlocks here will be able to access everything that uses a security group. Group rule, just like so, and we'll just call this ingress all, since we're going to allow any of the subnets that are provided within the CyberBlocks here will be able to access everything that uses a security group.
to access everything. Bikin DSG.
So we're going to say type equals ingress, then from port. Since we want to give access to us for every port, we'll start with 0. And then for to port, we're going to specify the highest port you can possibly specify, which is 65535. Then we need to specify a protocol, and for that, we're going to use -1. Now we need to use that in quotes here, and that basically says any protocol at all, where TCP is normally 6. -1 will include UDP, TCP, and ICMP. So we need to make sure that we have access to all of our protocols to our instances. And then we've got CIDR blocks. Make sure this is plural. This is actually a list here. So for this, we're just going to specify var.access IP, just like so. We're not going to provide any other access to this, at least not now, so that's the only one we're going to provide. And we'll create that here in just a second. And then security group ID equals AWS security group dot mtcsg.id. All right, so now we have our ingress all. Let's go ahead and create our egress all so that our instances can get to the outside world. So let's go ahead. Head, and I'm just going to copy and paste this right here, change this to egress, and this to egress, just like so. And then CIDR blocks, we need to change that to 0.0.0.0/0.
Oh, hello.
0, just like so. And we can put that in quotes. All right, perfect. So this looks good so far. Let's go back into our variables here, and let's get rid of our public and private CIDRs. We don't need those anymore. And then we'll do variable access IP. Type is going to be a string. Default equals. Now what you can do is you can go to something like ipchicken.com or some other website to find your own IP address. Since I really don't want to be throwing my IP address around to thousands and thousands of users, I'm just going to use 0.0.0.0/0 and leave it open to the world. Now I'll be destroying this quite frequently, so I'm not too worried about it. I do not recommend you do the same. Definitely go find your public IP address and place it in there. So again, this is in brackets already. So make sure that you provide the string that goes within these brackets.
Eh,
brackets. Now, if you didn't want to provide those brackets, you could remove them and then wrap the brackets around this and specify
Oh bisa.
a list of strings. That choice is totally up to you. If you already know you're going to be providing multiple IP addresses, you may want to do it this way versus the other way. But in my case, I'm just going to specify this string and leave the brackets around the variable here. All right, so that's really about it. Let's go ahead and do a Terraform plan, see if I missed anything. All right, 3 to add. We've got our ingress all, egress all, and security group all being added. So let's go ahead and run our Terraform apply and make sure this works. All right, cool beans, all greens. Let's go over to our overview. All right, we've got 16 resources now. Let's go ahead and go to the second page. We are getting a lot here. Now we have our MTC-SG, and it appears it's not going to show those rules as separate entities here. So let's go ahead and go hop into our VPC console and make sure everything was added. VPC at the set form apply.
Loh kan udah. Oh maaf maaf. Udah kok. For that access IP Terraform statless. Kenapa lagi gua nggak bisa? Frustrating banget gitu.
Make sure this works. All right, cool beans, all greens. Let's go over to our overview. All right, we've got 16 resources now. Let's go ahead and go these here. So everything is complete. So security for those resources now. Of strings. That choice is totally up to you. If you already know you're going to be providing multiple IP addresses, you may want to do it this way versus the other way. But in my case, I'm just going to specify this string
So stupid man. Tidur juga nggak bisa tidur. Ya Allah. Oh iya bener gak bisa berarti.
and leave the brackets around the variable here. All right, so that's really about it. Go ahead and go to the second page. We are getting a lot here. Now we have our MTC-SG, and it appears it's not going to show those rules as separate entities here. So let's go ahead and go hop into our VPC console and make sure everything was added correctly. So security groups, we've got our public SG here. Here. In Inbound rules all traffic from everywhere, which again should be your IP address here. Outbound rules all traffic. All right, so everything is complete there. We've got our security set up. Our VPC is mostly good to go. So go ahead and
Okay. Yeah, I think this last from now. For now. Ya, agak complicated gitu ya, padahal quite easy sih. Ya tinggal ini aja sih, terbiasa aja. Kita matiin dulu semua resource-nya. Lebih enak di ini ya, VS Code gini ya, kalau di online di Cloud9 itu nanti bermasalah di size ya, block size. Think that's enough for now. We're going to resume it tomorrow. Bye bye.